Hi there, everybody. It's Paul again. This time we're going to be talking about what artificial intelligence is and how data analytics fits towards it. So, there's lots of different definitions of AI. One of the definitions that I think is really useful is getting computers to exhibit intelligent behavior that's similar to what humans would demonstrate. So the term artificial intelligence was coined back in 1956 at the Dartmouth conference, and a lot of very influential and famous AI professors went to that conference. Some people like Marvin Minsky, who was instrumental in AI and in and had a big impact in neural networks, as we'll see later in the semester. One of the big ideas in artificial intelligence is this idea of intelligent agents. So intelligent agents are devices that can perceive their environment, and then they can take actions to maximize the chance of their success at some particular goal. So AI is often tied up with this idea of intelligent agents. Again, they're trying to exhibit some kind of intelligent behavior. The other definition, which I really like, is by a guy called Douglas Hofstadter, and he said that AI is whatever hasn't been done yet. It's a little bit of a joke, because it refers to something called the AI effect. And the idea is that as soon as a method which was called artificial intelligence, gets solved, it stops being artificial intelligence, it just becomes computing. And we've seen this in a lot of different areas. So, for example, the early days of search, doing things like depth first search or breadth first search of some kind of space, that used to be called AI, now it's just data structures. There's things like optical character recognition. So whenever you used to scan documents and then work out what the characters were, that used to be called AI. Now it's just called optical character recognition, and everyone does it. And things like timetabling, again, used to be an AI kind of problem, but now it's sort of pretty much being solved to some extent. So it's no longer AI. So artificial intelligence divides into two main approaches. There's the symbolic approaches, and then there's the statistical approaches. So the symbolic approaches tend to take a logic approach. So they try to encode ideas as theorems that they then prove in the logic. This was used a lot in the early days. The other approach is the statistical approach. And the statistical approach sort of is based on statistics. Things like decision trees, neural networks are good examples of the statistical approach. To be honest, the symbolic approaches have never really scaled up very well from toy problems. So there was a lot of hype about how well they would work, but then they just never really took off as well as people hoped. So the statistical approaches have really become dominant, and particularly these days with things like deep learning neural networks. So all of the artificial neural networks are all statistical approaches, and they've really been able to scale up to solve some big problems at sort of human scale. But they have their problems as well, because they don't really have a deep understanding of what's happening. So people have broken AI into a whole lot of common tasks that are often performed. So there's things like reasoning, where you're trying to reason out a problem. There's knowledge representation. How do we represent knowledge? And there's been a whole lot of approaches for doing that. Do we represent it in a neural approach, or do we use schemas or frames or things like this, which were used in the old days? Planning was and is a common task in AI. It's often used in robots. Learning, particularly machine learning, is a really big topic in AI. There's natural language processing, so trying to understand human text. And then there's perception, trying to perceive things, and pattern recognition is a part of that. And the ones that are marked in red, knowledge representation, learning, and perception, they're the ones that are more related to the data analytics. You could think of data analytics as being sort of associated with AI. And we'll be looking at learning this semester. Definitely we'll be looking at pattern recognition. We'll have a little bit of a look at knowledge representation. So if we focus just on machine learning, we can divide our approaches into two kinds. There's unsupervised methods and then the supervised methods. And we're going to see this quite a lot throughout the semester. We're mostly going to be looking at supervised methods, but we'll be looking at a few unsupervised methods as well. So with unsupervised methods, the AI is just trying to make sense of the data. So remember we talked about this in the last session. I'm just trying to understand the data or a problem through the lens of the data, so making sense of the data. And then the other approach is supervised methods. There we're trying to do prediction. So the AI learns some relationships between some inputs and an output from some old data, and then the AI then uses it to predict output for new inputs. And there's a whole lot of methods that fit into, well, for the unsupervised methods, there's things like clustering and association rule mining are good examples of that. For the supervised methods, there's things like classification, prediction, regression. We'll be looking at most of these this semester. Just to go into a little bit more detail about the unsupervised learning, here we're trying to make sense of the data set. So that blue block is supposed to represent like an Excel spreadsheet, just a set of rows. So each row in it is a new data point, and we're representing it in another form. We're trying to visualize it as maybe points on a graph. And we can identify groups that are similar to one another on the plot. So you can see all the blue ones are similar to one another, but they're quite different to, say, the green ones. We might be trying to identify frequent patterns in the data. So that's the idea between frequent pattern mining or association rule mining. And we can use different methods like clustering, association rule mining, and some kinds of neural networks to do this unsupervised learning. But we're going to come back to this in a few weeks. The other approach is supervised learning. Here we're trying to make a prediction. So we have our existing data, so here's our blue rows, but we also, and we call that our inputs, but we also have something that we know about that data. So let's say, for example, that each row in our blue block there is a student in the class last year. And we know a whole lot of things about that student. We might know their student ID, we might know if they're part-time or full-time, what course they're in, things like that. And we also know something else, and that's what's in the red one. The thing we know is maybe whether the student passed the class or not. So what we do with supervised learning is using that old data, we learn the relationship between the inputs, so the course that they're doing, whether they're full-time, part-time, all of that, to be able to predict whether the student passed or failed the subject. And we know the answer because we know it from last year. And the idea is once we have learned that approach, we can then use it for new data. So here on the right-hand side, that top blue bar, that's a student in this class. Maybe it's you. So we know whether you're part-time or full-time. We know what subjects you did previously. We know all of that information. But of course, we don't know whether you passed the subject or not because it's the start of the subject. So we ran that through our machine learning algorithm or our artificial intelligence. And then it will spit out the answer, yes, you failed, or sorry, yes, you passed, or no, you failed. And that's a general approach. So we can either do it in that way where it's a yes or a no, or we could do a number. We could maybe predict the mark that you'll get, and that's called regression. The first is called classification, where there's discrete values, yes or no, or pass, fail, credit, distinction, high distinction, and regression is where you're predicting a number. And we can do it using things like decision trees, neural networks, other types, things like support vector machines, and a method called random forest. And we're going to be looking at all of these this semester. Okay, that's all from me for this